Okay, which has a greater O-NO bond angle, NO2 or NO2 plus 4, NO2 minus or NO2 plus 4 bond angle. So with that being said, we need to first figure out what the Lewis structure for these would be. So nitrogen, okay, how many electrons it offers? It is on the 15th column, okay, and for those ones, they have 5 electrons they can contribute. And you can actually also see this by doing the electron configuration. You'll see that it ends in 2p3 plus the 2s2. It will be in total 5. Oxygen, you see it's in the 16th column. So with that being said, it can offer 6. And same thing here, 5 and 6. But there's 2 oxygens in each one, so that would actually be 12. But we have this minus here, okay, meaning we have an extra electron. So 5 plus 12 plus 1, that'd be 18 in total. And for this one, it would be 5 plus 12, but there's a positive, meaning that would be minus 1. So 5 plus 12 minus 1, we have 16 electrons we are dealing with, okay? So let's first draw out the Lewis structure for NO2 for the 18. So we have nitrogen in the center, and we have 2 oxygens, okay? And oxygen are here. Oxygen now, it needs to incorporate the rest of its 6, so it'll be 2, 3, 4, 5, 6. Same with this, 2, 3, 4, 5, 6. And nitrogen is right now sharing 2 of its 5, so 3, 4, 5. So what can actually happen here, okay, is that these 2 will be able to go over here to form a double bond. In fact, let me just draw it a little bit better. Make this nitrogen alone up here. Oops. 4, 5. And these 2 will form here into a double bond. Alright. And then we notice that we have this lone pair here, right? Well, thankfully, as was stated earlier, we had 1 extra electron, so that's where it would go there. So NO2 minus, that anion, would be like this, to where it has 1. But over here, as we mentioned, it'll be a double bond, and it'll be there. Still a lone pair on the nitrogen, and this. So this would be NO2 minus. And the theoretical formal charge for each, it would be nitrogen, it likes to have 5 electrons based on the periodic table. So it would be sharing, well, it would be not sharing 2 electrons and sharing 6 electrons. So that's 2 plus 3, that's 5, so it's 0. The oxygen to the left is 6 minus, it's not sharing 4, but it is sharing 4. That's 4 plus 2 is 0, perfect. And the oxygen on the right, 6, it's not sharing 6, but it is sharing 2, and that's 6 plus 7, so that's minus 1. And it makes sense because that's where the negative charge is for NO2 minus. So that's what we have here. To determine the electron geometry for this, okay, it would be, it's attached to 3 things. So 1, 2, 3. So that means 3 electron geometry, and that is a trigonal planar for it. And then because it has 2 bonds and 1 lone pair, the shape is going to be bent. And so we just kind of know it looks like this. The lone pair right there. And the angle is like around, if each one was 120 degrees, it would be less than 120 degrees. That's what we know. Alright, so there's a 2:1 ratio bent. Now, for NO2 plus, this one is going to be drawn very similarly as what we just did. Okay, where we have the oxygens, and then we have oxygen wants to have 5, 6, 3, 4. Yep, that's done there. And now nitrogen has 1, 2, 3. Now I'm actually going to take out 1 electron, and I'm going to choose this one here because if you notice, Now we actually have 16 if you counted it. So it's 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And you can see here that these ones would form that double bond along with these ones to form a double bond. So No plus, just by getting rid of one electron, would be like that, with these bonds here and these bonds here. So with that being said, the formal charge would be 5 in the middle. It's sharing now, as you can see, has 0 by itself, but sharing 8. That would be +1. So the nitrogen is where that +1 is going to be, which makes sense. And you should see actually the oxygens are each going to be 0 for their formal charges, because it'll be 6 minus has 4 by itself plus 4 over 2. That's 0. So that's for each side. So there we have it. So for this, as you can see the shape here, it only has 2 bonds attached to it. So it has a formal, electron configuration, not configuration, the electron geometry, it would just be linear because there's only 2 bonds. And because there's no lone pairs, it's still going to be 2, 0. So it's going to be stay its linear shape. And with that being said, it's going to look like this, where the bond angle between is going to be actually equal to like 180 because it's a straight line. Okay, double bond there, double bond there. And so they asked in the original question, which has the greatest bond angle? Based on this and everything we've done so far, we have one that's less than 120 and one that's 180. So the No2 plus, okay, that would be our answer, is going to have the greater bond angle between the two, because based on the Lewis structure and the electron and molecular geometry, that one is going to be a linear shape, while the No2 minus is going to be a trigonal planar, which goes down to bent shape. Okay, it's like the molecular structure is bent, angle is 115, and this is linear, angle is 180. So the difference is due to the lone pair present in No2 minus, but not in No2 plus. And this is correct. Now let's move on to question number 16.